Okay, so complex fractions basically take everything that we have done this unit and it puts it into one problem. So it's a combination of addition and subtraction, where you have to get common denominators, and then it's going to turn into a division problem, and then it's going to turn into a simplified problem. So basically everything that we've done in this unit, but in the backwards order from how I've taught it to you. So we're first going to add and subtract, then we're going to divide, and then we're going to simplify. Okay. So basically when you look at these, you have fractions within fractions. So like double the fun. Your goal for these is to end up with a single fraction on top and a single fraction on the bottom. And how you're going to do that is first just add or subtract the numerator. Completely ignore what's happening on the bottom. Once you get that cleaned up, then you're going to deal with the denominator, and then you're going to divide. And for the division ones, these are all going to end up being double-decker fractions. So you could sit there and rewrite it as an old school division problem and then flip it, but I really want you to try to get away from that, because this kind of thing with a double-decker fraction is going to keep coming back up. And I think even if you might be a little uncomfortable with it now, in the long run, I think that this method is better. Okay, so I will be drawing lots of hamburger buns and patties today so you can remember how these go. So as a reminder, the way this analogy works, and I just put a really simple a over b divided by x over y here. Think of these the very top and the very bottom, as your hamburger buns. Can you see those? Yeah, good enough.
Did Miss Danhoff buy those?
No, these ones are mine. These pens Mrs. Danhoff did buy for me, though. And these guys on the inside, these are your patties. You can only do this if you have a single fraction on the top and a single fraction on the bottom, though. Okay. So the buns are going to go together, and they get multiplied together. So it's a times y in this scenario over the patties multiplied together, so b times x. Then you'd look to see if you can simplify, but since all four of those are different letters, we're stuck. Okay, but I wanted to put that on there so you can, like, if you're ever not sure of like how the brackets go, look back at that. But literally, I'm going to draw these every time, because I think it helps too. And because I like to draw things, even if they're terrible. Okay? So let's go ahead and take a look at number one. I'm going to cover up the bottom. Let's just look at the top. If I want to put those together, for starters, the second number is not even a fraction. So anytime you're dealing with fraction and non-fraction things, change the non-fraction thing into a fraction. So we're going to start by putting this 2 over 1. Okay, now if you look, what will be our common denominator between 32 and 1b? 32. So I'm going to multiply this second fraction by 32 over 32, and we don't have to multiply the first one by anything. So what we're going to have is x squared over 32 minus, when we multiply these two together, we'll have a 64 on the top and a 32 on the bottom. I'm not even dealing with the denominator yet. I'm going to go ahead and put those together. So really we just have x squared minus 64 all over 32. And you might be sitting there thinking, like, we can factor that. And you could factor it now if you want. We'll get there. So you could just factor it later. But that's our numerator. Now we're going to do the same thing, but on the bottom. This way. What's going to be your common denominator between 16 and 2? 16. So what does the second fraction need? 8.
I'm like skipping ahead.
It's okay.
That's
okay. All right, so this one doesn't change, so x over 16 minus, this one will be 8 over 16. They have the same denominator, so we can smush them together. So x minus 8 over 16. Now we have a single fraction on the top, single fraction on the bottom. Here come my beautiful diagrams. We got 2 buns, 2 patties. Put them together. When you put them together, just write them side by side. And if anything has addition or subtraction in it, make sure you put it in parentheses. So the 16 and x squared minus 64, I'm going to write like that. And the 32 and the x minus 8, I'm going to write like that. You don't want to multiply it out because in order to cancel and simplify, it has to be in factored form. And while this isn't completely factored, it is technically a factored form. Because when you see here this 16 and the 32, because they're both on the outside of a parentheses, you can go ahead and reduce those now. All right, so what's 16 over 32 is going to reduce to what? 1/2. So this becomes a 1, this becomes a 2. So already it's simpler. And what can we do with this? Yep, x minus 8 and x plus 8. At which point, then you can cancel out the x minus 8s. That's kind of a mess, but if you look, what we're left with up top is a 1 and an x plus 8, so just x plus 8. And on the bottom, all we have left is a 2. Yeah, you can put the 1 there if you want. Now, does this equal x plus 4? Okay, good. I'm going to say okay, good before anybody says yes, because that's all you can do. Okay, fraction on top, get it together. Like common denominators, same thing on the bottom. Group it, and then simplify. Not too bad, it just puts everything together. All right, let's look at the second one. So if I just look up top, what does the first fraction need that the second one has? X. And what does the second fraction need that the first one has? 3. Okay, again, I'm completely ignoring the denominator. So we're going to have a 2x over 3x and a 6 over 3x. Which you could then put together to make 2x plus 6 all over a single 3x. Now, if you're sitting there saying, well, like, I would just go from here straight to here. You can if you want to. So, like, but I'm saying, like, if you want to skip writing down this and you're comfortable going straight to here, that's fine. I just find that a lot of times, like, if I skip showing this step, it's a little much for some people. So I'm going to keep showing this step, but know that it's cool if you jump from here to here. Okay, numerator is done. Down to the denominator. What does this first fraction need that the second one has? Yep. And the second one needs a 3. So it doesn't always happen like this, but sometimes you might find that the numerator and denominator just end up happening to have the same common denominator. It is what it is, but it's not always going to be like that. So we'll have a 5x over a 3x plus a 15 over 3x. Put it all together. 15, oops, 5x plus 15 over 3x. What can I draw now? Hamburgers. I feel like this one looks more like a taco. But an artist I am not. Okay, so outsides, the buns go together. I'm going to put that 3x, just let it float outside that 2x plus 6. Yeah. Oh gosh. Sorry. All right, and then down on the bottom, the patties. What happens with those 3 x's? Okay. What can you take out of what's left up top? 2. So with x plus 3. And you can take a 5 out of the bottom. Heck yes, they do. All of that work to get 2/5. Woohoo! It's not. When you watch me do it, it's not bad.
No, but like I still
Okay. You do. You do. But the thing is, like, I think the hard thing about this unit is knowing what order to do the steps in.
Oh, it's numbers. Love that. Granted, mixed numbers
Yes,
aren't
the
that
next
bad.
one has exponents.
It's just 1/1.
Okay. But the exponents aren't bad. It's when we get to like where like 4, 5, and 6. Notice how there's addition and subtraction in those denominators. That just requires a little bit more care. It's fine. Okay, let's take a look at 3. Now, again, we're ignoring the bottom. What does this first fraction need that the second one has? X. And the second one needs a y. So when you multiply them together, we're going to get a 3x over xy plus a 4y over xy. Which, when you smush them together, will give you a 3x plus 4y over xy. We're going to let that sit for a second while we deal with the bottom. Any questions on that so far? Okay, let's look at the bottom. What does this first one need the second one has? X squareds. And the second one needs y squareds. So we have a 9x squared, oh shoot, I'm doing it in the right spot. 9x squared over x squared y squared minus 16y squared over an x squared y squared. Are you already seeing how this is going to simplify? Like, it is a lot of work, but this here is going to be a 9x squared minus 16y squared all over x squared y squared. Woo! Okay. So in the numerator, you just have a 3x plus 4y over xy. In the denominator, we have a 9x squared minus a 16y squared all over an x squared y squared. Here come the burgers. Buns first, always. But like, I never put 2 pieces of cheese on a grilled cheese. I just put 1. Yeah. I don't know. Don't judge me. Okay. Maybe she's lactose intolerant. You don't know. Okay. Let me remind you, I'm recording these, so this is nice. Thanks, guys. I didn't mean to. All right, these two down here, xy, and then a 9x squared minus 16y squared. I would look to cancel first. All right, so here, look at these guys out front. One of these x's is going to cancel out the one that's on the bottom. One of those y's is going to cancel out that one that's on the bottom. What kind of factoring are you going to end up doing with this? Perfect squares. Okay. So I'm going to go ahead and scratch out this squared and scratch out that x. Okay. I'm going to scratch out this squared and scratch off that y. And then this is going to factor into 3x plus 4y and 3x minus 4y. I did perfect squares. This cancels this, and your final answer, and I'm going to write it this way, which is weird, but I don't want to ruin my space over here. All that's left up top is an x and a y, and we have a 3x minus 4y on the bottom. Don't even be tempted to cross off those x's and those y's. That is it.